Assalamu alaikum everyone. I am Sabiha Akter, ID 2301002. My team members Ahammed, Shoyaib, Hisham, ID 2301009 and Shihab Uddin, ID 2301025 from the Department of Internet of Things and Robotics Engineering, University of Frontier Technology, Bangladesh. Today we are pleased to present our project UniSphere Intelligent Campus Networking System Design and Implementation using Cisco Packet Tracer. This project was completed as a part of our Computer Networking Sessional course. Throughout this presentation, we will discuss the objectives, design, implementation, result, and future scope of our project. So without further delay, let's begin with the project objective. The main objective of this project was to design a smart campus network that can support multiple departments while maintaining security and efficiency. To achieve this, we implemented VLANs for network segmentation, inter-VLAN routing for communication between departments, DHCP for automatic IP assignment, DNS for hostname resolution, OSPF for dynamic routing, wireless networking for mobility, ACLs for network security. Our goal was to build a network that is easy to manage, secure, and scalable for future expansion. Today, educational institutions rely heavily on computer networks. Students, teachers, and administrative staff use laptops, smartphones, and various network connected devices every day. A traditional flat network can create severe problems such as excessive broadcast, traffic, security risks, and difficult management. To overcome these challenges, modern networking technologies are needed. This project demonstrates how a well-designed campus network can improve performance, security, and overall network management. Core theory of our project, several important network technologies are used this project. First, VLANs divide the network into logical segments, reducing unnecessary traffic and improving security. Inter-VLAN routing. Inter-VLAN routing allow devices from different VLANs to communicate when required. DHCP automatically assign IP address to a device, reducing manual work. DNS convert domain name into IP addresses, making network secure, easy to access. OSPF is a dynamic routing protocol that automatically select the best path for data transmission. ACLS or access control list help control network traffic and prevent unauthorized access. Finally, wireless networking. Wireless networking allows mobile device to connect securely to the campus network. Our network uses a hybrid topology, which combines the advantage of star, tree, and point-to-point topologies. The network consists of three main layers: core layer, distribution layer, and access layer. The design improves scalability, simplifies management, and ensures insufficient communication throughout the campus network. Thank you. Now I would like to hand over the presentation to my teammate.
Thank you. Now I will explain the configuration process used in our project. The implementation started with VLAN creation to separate departments into different logical networks. Next, trunk link were configured to carry traffic between switches. After that, inter-VLAN routing was configured to allow communication between different VLANs. We then configured DHCP and DNS services. OSPF routing was implemented to provide dynamic route selection. Wireless networking and ACL security policies were also configured. Finally, connectivity tests were performed to verify that all services were functioning correctly. This slide shows several configuration screenshots taken from Cisco Packet Tracer. These include VLAN configuration in the left part, and in the middle part there is trunk configuration, and in the right part this is inter-VLAN routing. There are also some screenshots from Cisco Packet Tracer. In the left part, we can see that there is DHCP configuration, and in the middle part, OSPF configuration, and in the right part, wireless configuration. This screenshot demonstrates the practical implementation of the technologies used in our network. After completing the configuration, we performed several tests. Ping tests were used to verify connectivity between devices. DHCP tests confirmed that devices received IP addresses automatically. OSPF routing tables were checked to ensure successful route exchange between routers. This test showed that the network was functioning properly and all major services were operating successfully. During implementation, we encountered several challenges. One issue involved communication failures between VLANs due to configuration errors. There were also DHCP-related problems involving address allocation. OSPF neighbor relationships occasionally failed because of incorrect settings. DNS resolution issues were also identified during testing. These problems were solved through troubleshooting, configuration verification, and proper network planning. Security concerns were addressed using access control lists to restrict unauthorized access. The project achieved all of the primary objectives successfully. VLAN implementation reduced unnecessary broadcast traffic. DHCP simplified IP address management. OSPF provided efficient and dynamic routing. Wireless networking improved accessibility and mobility. ACLs enhanced network security by controlling traffic flow. Overall, the network performed efficiently and demonstrated the effectiveness of modern campus networking technologies. Thank you. I will now pass the presentation to our final presenter.
Now I will discuss the advantage and limitation of our project. I have some key of advantages included better traffic management using VLAN equipment, automatic IP assigning using DHCP, efficient routing through OSPF, and improved security ACLs and wireless access for mobile user, easily scalability and network management. However, there are some limitations. The project was implemented in Cisco packet tracer, so it based on simulation. Real-time hardware performance and large-scale development were not tested. Advanced security features such as IDS and IPS enterprise firewall solution were also beyond the scope of the project. In conclusion, the UniSphere project successfully demonstrates the design and implementation of secure and scalable campus network. The integration of VLAN, DHCP, and DNS, OSPF networking, and ACLs created an efficient and management network environment. The project also provided an valuable practical experience in network design, configuration, troubleshooting, and management. Implementation roadmap. Moving forward, and several improvements can be made. The first step of validating the network larger scale, additionally security mechanisms such as the firewall, IDS, and IPS can be implemented. Network monitoring and quality service can also introduce to improve performance and visibility. Finally, the cloud integration and IPv6 support can be added, modernized, and infrastructure. Future work. There are many opportunities for future development. This include expanding the network infrastructure and implementing advanced firewall solution, developing IDS and IPS systems, integrating cloud-based service and adding a redundancy of failure mechanism, and implementing IPv6. Enhancing wireless security, introducing the monitoring system and quality service. Their improvement would make network more secure and reliable and suitable for real-world development. References. We have also taken from many other sources. So, for this project, we used information Cisco Networking Academy resources, Cisco documentation, networking textbook, and Tenabium and Stelling and CCNA official study guide. These references help us understand the implemented the network concept used in this project. This concludes our presentation. Thank you for your time and attention. Assalamu alaikum.